Hello, everyone, and welcome to the Varsity Tutors StarCourse series, where today we're going to be taking some time to learn about some pretty cool science with our friends at the Omaha Children's Museum. Our friends from the museum, the Snow Queen, will be showing us some of her favorite frigid and frosty experiments, and we'll even get the chance to follow along with one of those experiments at home. Now, to follow along with today's experiment, you'll want to have the materials that are listed on today's class description handy. So that's baby oil or vegetable oil, white paint, Alka-Seltzer tablets, a clear glass jar, and possibly some glitter or blue food coloring if you happen to have it close by. Now, as we experiment along in today's class, you also might find that you have some questions, and the Snow Queen will have some questions for you too. So feel free to use the chat on the right-hand side of the screen to both ask and answer questions throughout the class. And if we don't get to those questions right away, not to worry, we're going to save a couple of minutes at the close of the lesson specifically for Q&A with the Snow Queen. You'll also want to be sure that you have your cameras close by, because toward the end of the lesson, we're going to have the opportunity to lean into the screen for a selfie. And if you post those selfies on Instagram and you tag us here at Varsity Tutors and the Omaha Children's Museum, you'll be entered to win a 1-month membership to the after-school club of your choice. Now, we'll talk a little more about the details of that prize when we get to the end of today's lesson, but for now, I'm going to go ahead and pass things along to your instructor for today, the Snow Queen.
Hello. It's so nice to be able to spend today with you. Oh, this is just my favorite time of year, winter. Well, at least it's winter where I am. Is it winter where you are too? Have you ever been somewhere where it's very, very cold? Well, I love being in the cold. Oh, it makes me think about snow and wind and ice. In fact, have you ever wondered about the science of any of those things? Well, if you have, you're in luck, because we're going to learn all about some freezing cold science. So why don't we get started? We'll start with one of my favorite things, snow. So it's a little hard to bring snow inside. It's pretty toasty indoors, but I have a very special powder with me. Why don't we take a closer look? I'm back. So here we are, this is called polyacrylate powder. And what it is very good at doing is absorbing water. And I just so happen to have some water right over here. So we have all these little powder bits, and they soak up water. It's going to become many, many, many times its size. And we wait. So when something absorbs, think like a water balloon. Does it get bigger or smaller? It gets bigger, right? And it expands and expands and expands. And then right before your eyes, you get this here. Let's take a look. And our polyacrylate powder looks like snow. Oh, can you imagine what it feels like? It's even a little chilly. You know, if I didn't know, I'd think this were real snow. Wouldn't you? Wow, now that we've talked about my favorite thing, let's move on to something a little bit more interesting, the wind. It sure can get windy when it's cold out. But have you ever wondered how wind works? Well, let's talk about it. So that is caused by heat, surprisingly. So when the sun heats up the earth or the air starts to expand. It warms up and gets bigger. Molecules, the tiny little things that make it up, move farther apart, so they're less dense. Warm air is less dense and has low pressure. So that warm air starts rising up, and then as it moves, the cold, dense air with the high pressure fills it in. So as that air is moving, well, moving air is just another way to say wind. So why don't we have an example of that? Let's look at some wind and some low pressure in action. So right over here, what does this look like? If you guessed a slip of paper, you would be right. Now, my plan is to show how air is moving and how pressure affects it. So I'm going to get this strip of paper to move by blowing on it. But not like this. That is a solution. But rather, I'm going to blow on top of my piece of paper. So let's see what happens. Oh, let's look again. So what's happening? Well, when I blow on my piece of paper, that moving air creates lower pressure. And that higher pressure pushes up that piece of paper. See? So it's nice to look at on a strip of paper, but I think we can do a little bit better than that here. Oh, where did that blizzard go? Oh, that silly thing. Oh, here we are. The royal blizzard blower. So you might recognize this is a leaf blower and some toilet paper. So we're going to have this is like me blowing on top of the paper, creating that low pressure. And well, let's see what happens. Are you ready? All right, let it blow, let it blow, let it blow. Oh, now that was a lot more exciting than just a strip of paper, don't you think? Now, I really enjoy the science of heat and wind, but we've already talked about snow and we've said a bit about wind. Why don't we talk about ice? Oh, my entire castle is made out of ice and I just love it. Oh, it's perfectly smooth and shimmery and frosty in every way that I like. But my castle is made out of ice, which is frozen water. But now, did you know that water isn't the only thing you can freeze? As a matter of fact, you can freeze gases as well. So here, I'll show you. So right over here, I have, well, my safety gloves, because what we're going to deal with is a lot colder than my ice castle. So safety gloves, we're going to work with what's called dry ice. Has anyone ever heard of that before? You might have heard of it, for example, at the grocery store. Maybe a girl of yours has bought some. Well, it's not frozen water, it's frozen gas. Let me show you. So right here, I have some dry ice. Now, what normally happens to ice made from water when you get it really warm? It starts to melt, right? It turns into water. So a solid turning into a liquid is called melting, but this isn't turning into a liquid. Here, let's get a little closer so that you can see. Right over here, it is turning into a gas. You might be able to see it. So when a solid turns into a gas, that's called sublimation. Can you say that word with me? Ready? Sublimation. And dry ice sublimates. Unfortunately for us, there are a lot of fun things to do with it. So here, I'm going to get some teeny tiny pieces of dry ice. And right over on my science table, I have some film canisters right over here. Now I'm going to take a piece of dry ice and pop it in. Now to speed up the sublimation process, we'll get it a little warmer with some water. And then I'm going to put on the top of my film canister right away. All right, so I've just put in. Oh, there we go. Oh, it happened very quickly. Let me try it again. All right. So the film canister, oh, it's working too well. There we go. The film canister had him a dry ice, and then it started sublimating right away. And so as it sublimated, that air pressure, that carbon dioxide started spreading out and making pressure, pressure, pressure until the top popped. think we should try it again? All right, why don't we? Maybe I'll use a little bit less dry ice and we'll see how it works. All right. So here we are. I have my film canister with my dry ice. Pouring in some water to speed up that sublimation. Popping on my top. Now we wait. If you wanted to, with some adult supervision, you could even try that experiment at home. Let's see if it pops again. If it, oh! I know it's coming, but it gets me every time. Well, we're not done with our dry ice experiments. So we talked about how it's sublimating and creating a gas. Now, what do you think would happen if I used, say, some water and I just dropped some dry ice into some water? And what do you think would happen if I added some soap? Well, only one way to find out. So I'm going to put back on my safety gloves and get some dry ice. So the reason that I'm wearing my safety gloves is because dry ice is a lot colder than frozen water. So dry ice is 110 degrees Fahrenheit below zero, which is pretty cold. All right, so I have here some dish soap. I'm going to pour some into my water. Ready? Go. And then I'm going to drop in my dry ice. All right, 3, 2, 1, science. Oh goodness, do you see all the bubbles it's making? And what's even more fun about these bubbles is that they're filled with carbon dioxide. So these are also affectionately called ghost bubbles. This is also a very simple experiment to try at home with your grown-ups. A lot of fun, right? Now, dry ice is pretty exciting, but it's not the coldest thing we're going to be working with today. In fact, we have something much, much colder. Has anyone ever heard of liquid nitrogen? It's very cold. So I'm going to put my safety gloves right back on. So does anyone remember how cold dry ice is? Well, that's right. About 110 degrees below zero Fahrenheit. Well, liquid nitrogen is much colder than that. So before we get started, what does this look like to you? If you said a banana, you are absolutely right. You know, I used to have a whole bunch, but it split, so now I'm just left with 2. But I have a feeling you might enjoy this next experiment. So I have here my very special, very cold things bucket. It's a thermal bucket. So we'll put our banana in the bottom, and then I'm going to fill this with liquid nitrogen. All right. Standing back, being safe. So liquid nitrogen is actually 320 degrees Fahrenheit below zero, which is very, very, very cold. All right, have my bucket nearly filled up. All righty, so that banana is going to sit in its little bag. And I'm going to get the lid on as quickly as I can. So while I'm doing that, I have another question for you. What does this look like? It's a balloon. So do you remember we talked about air pressure? And when air heats up, it expands. Well, if it expands when it heats up, what do you think it does if it were to get really cold? Would it expand? Would it stay the same? Well, let's take a look. We can try with our balloon. So I'm going to put my balloon in my bucket. Now you'll notice that I'm moving. Whoa, what's happening to my balloon? It's shrinking. So when something gets very cold, the molecules move closer and closer together. Do you see how tiny my balloon is now? But what do you think happens when it warms back up? Wow, the air is expanding again. That is pretty neat, don't you think? Do you think it's about time to check on our banana? Let's take a look. Now I have here some tongs as well. We're going to fetch our banana. Lid back on. Now, we'll see what happened to it. Now, if the molecules, when things get cold, move closer together and get more dense, do you think that they would be harder or softer? Well, should we take a look? See if I can kind of smush it. Oh, smushing doesn't seem to be working. It seems pretty stiff actually here. Let's see if I can nail in a nail with my frozen banana. Oh my goodness. I'll try again. Now that is a cold banana. Have you ever seen a banana shatter and break before? Well, me neither. The science of cold is pretty neat, isn't it? All right, well, I have yet another question for you. What does this look like? Have any of you ever had tea or coffee or maybe even my favorite, hot chocolate? Well, then you might have used one of these before. This is a tea kettle used for boiling water. And it's my favorite kettle and my favorite type of kettle. So this one, when the water boils, it whistles to let you know that it's ready to go, that the water is boiling. So when the water boils and it's moving around that air, it's going to push that air right out through here. And you'll see, I'll come a little closer. Okay. You'll see that there's a very small hole in the kettle. And so if you whistle, you're going to make your mouth just like the top of my tea kettle. But do you think I could get my tea kettle to boil and whistle even without something hot, even without hot water in it? Well, as it happens, I think liquid nitrogen just might do the trick. So first we'll see if there's any left in here, and then after that we'll get some more. All right. Pouring in our liquid nitrogen. Up on top. Oh goodness, a little. Try it again. Oh, wow. So it just so happens you don't necessarily need hot water. You just need a liquid that boils. Pretty neat, right? Now, I have one more experiment for you with our very cold liquid nitrogen. And that is we are going to make our very own super thick fog. So I have here a beaker, and I'm going to put in a little bit of liquid nitrogen. All right, so I have liquid nitrogen in my beaker, and I'm going to pour it into my Erlenmeyer flask. Wow! Do you see that? Do you see how thick that fog is? Wow. And if you notice, because it's so cold, the gas molecules are very close together and more dense than the air around it. So my fog is sinking. And you can't feel it, but I'm sure you can imagine at home, it's pretty chilly too. What do you think? Well, thank you so much for coming through to watch the science, but don't worry, we have more to come. So up next, we're going to do our at-home experiment. All righty. So make sure that you have your items ready to go so we can do this at home. And don't worry, I'll leave some time for you so that we can do it in real time together. All right, so we are getting set up. Curtains are closed. All righty. So this is a great time to make sure you have your jar and your water, your paint, your glitter, your watercolor, or anything else that you plan to use. Okay, ready to go? All right. Well, I won't be needing my safety gloves for this one anymore. There we are. So remember, first thing you're going to need is a glass jar. Now make sure you take the lid off first, or this is going to be a lot more difficult. Okay, lid is off. And then if you could go ahead and fill it about 1/4 of the way with water. I'll do some steps with you, but not all of them. So we'll fill it about 1/4 of the way with water. Very nice. So once you have your water in the jar, your next step is going to be to add a few drops of paint. So we're going to open it up and then put in some paint and stir it. So the consistency should be about of milk. Don't drink any, but it should look like milk does. All right, so if you put in your paint, all right, now go ahead and stir that paint up in the water and make sure that it's enough so we have the right consistency. Looking good? All right, perfect. Now, the next thing that you can do is we're going to add in our baby oil. Now you can use another oil as well, vegetable oil, but it will look a little bit different. So the baby oil is usually best if it's clear, but yellow works just fine too. You can still do the experiment. So we're going to fill up our jar the rest of the way. Not all the way to the top, but about to here, right? So that it's not going to spill all over the place. We can still hold it and put the lid on safely. So go ahead and pour in your baby oil. Right, have you got it? And if you make a mess and have to clean it up, that's all right, because you have the instructions with you. You can keep on going. All right, our next step is to add in our watercolor. So if you have any blue watercolor, now is the time to put in just a few drops. A little goes a long way, and it should still look very blue or pink or orange or whatever color you chose. So add in your watercolor. Perfect. All right, and then our next to last step is extra. If you'd like to add in a pinch or two of some glitter, silver and gold are my favorite, but whatever makes your heart happy. So add in a pinch or two of glitter, just for some extra magic. All right. Do you have your pinch of glitter in? Perfect. So I made one earlier. Swirl it around a little bit. So if you see, we have the water down here with the coloring in it and the baby oil up here. So if you notice, they're not really mixing together. Here, I'll get closer to the camera so you can look a little bit better. Do you see? So our water's down here and our oil's up here. So our water, do you remember we talked about density and how, for example, hot air is less dense because the molecules are further apart. It's the same way with the oil. So the oil is on top because it's less dense. And the water is on the bottom because it's more dense. You notice they're also not mixing together? There's a very special word for that called immiscible, which means basically unmixable. You can try really hard. I can shake this and it's still going to separate. All the oil is going to sink to the bottom, right? But we're not quite done because we have our very last step to make our snowstorm in a jar. 1 second, I'll get back to my table. So for our very last step today, we need some Alka-Seltzer tablets. You have the lid on top of your jar like I did. Take the lid off if you didn't put your lid on. Good job. All right. So I'm going to break mine in half. You can be a scientist and see how it works with a full tablet or a half tablet or a quarter tablet. Then we're going to take it and drop it in and see what happens. Oh, wow. In fact, I'm going to drop in a little bit more and it sinks to the bottom. So let's get a really good look at what's happening here. Can you see? Here we go. Do you see how it's raining up and then coming back down? Do you see your snowstorm happening? Well, Alka-Seltzer tablets have baking soda in them. And when that comes into contact with water, it creates carbon dioxide. And that gas is very light. It's much less dense than everything around it. So it grabs a little bit of that water and watercolor and paint and lifts it through the oil. And then the oil pushes it back down. Here, let's try one more half tablet. There we go. And so you can create your very own snowstorm in a jar. Here, let's get a good angle. Woo! Very nice. Ah, there it goes, there it goes. And what's very nice about this specifically is that you can keep this jar around and it's still good. All you need to do is replace your Alka-Seltzer tablets. I hope that was fun for you. It certainly is fun for me, but don't forget to put the lid back on. I forgot that once. There were no winners involved. All righty. I'm going to clean up some of my equipment and we'll move to our very last experiment. Alrighty. Here we go. I'm really excited for this one. I don't know if any of you have ever done any magic before, but it's very fun. Have you ever done magic? Have you thought about it? Well, we'll get to do some magic together. So, I have over here different locations. You see? And what we're going to do is I'm going to let you fly around a magical world over here to different locations. But I bet I can find you wherever you land. So here, let's go through. We have the North Pole, yes, the Sea of Ice, Snow Queen's Ice Castle, my personal favorite, a blizzard. Oh no! Right over here is the Frosty Forest, Polar Bear Mountain, the Frozen Bridge, Cloud Canyon, Penguin Pond. Oh, they are very cute. The Icicle Cave, the Winter Cabin, and then our Snowflake Gardens. So what I need you to do first is to pick someone who can point to the screen. So in your group, whoever's watching, if it's just you, you're it. But if you're in a group, pick one representative to go up to your screen who can point to the different locations. And so everyone else can see too. All right, do you have your person? Is that person in front of the screen? Perfect. So now what I need you to do is to pick out a secret number. It doesn't have to be secret in your home, but don't try to tell me. That's the point. You'll choose your number, and I'll be able to guess where you are. All right? So your number has to be between 5 and 15. You ready? 5 and 15. Do you have your secret number? All right, don't forget it. Keep that secret number in mind. You got it? Perfect. So we're going to start here and then move along in this direction. So for example, if your number were 6, you would go 1, 2, 3, 4, 5, 6, and end up at the blizzard. So should we do that together? All right, so we'll start here. 1, 2, 3, 4, 5. Now you keep going until you get to your secret number. Okay? And don't tell me where you land. All right? You gotten to the final position? Keep your finger there, don't forget. All right, so you are pointing to where you landed. Now we're going to move again, the same number of spaces, but this time in the opposite direction. So as an example, I'd go 1, 2, 3, 4, 5, 6, and end up at the icicle cave. But you move your secret number in the opposite direction. Ready? 1, 2, 3, 4, 5. Now keep going until you hit your secret number. Are you there? Did you get there? All right, perfect. Now let's narrow things down a little bit. I'm pretty sure I know not where you are, but where you're not. So let's see here. Snowflake gardens. They're lovely, but they do get a little crowded this time of year. And let's see here. Cloud Canyon. Beautiful, but a pretty foggy destination. I don't think you're there. Polar Bear Mountain. They really are friendly, but it's kind of tricky to get stuck there sometimes. And oh, the blizzard. Well, we'll just take that down now. I hope you're not there. All right. Okay, so we're going to move one more time. This time, you can move in either direction, but only 4 times. So remember where you are. Move 4 spaces, either this way or this way. You get to pick. Ready? 1, 2, 3, 4. All right. Don't lose your place. Okay. Now, I'm not sure where you are, but I'm sure where you aren't. Okay, let's see here. So the sea of ice. It really is a lot of fun. The seals are so delightful, but I'll tell you, sometimes they don't like it when company comes and they're trying to swim. And then, icicle caves are gorgeous, but a little slippery this time of year. And the winter cabin is so cozy, but I bet you're not there either. Let's see. Now let's stop. I got it. I bet I could use a little bit of magic to help me out. All right. I'll say, let it snow, let it snow, let it snow. We'll see. Right? Ready? Let it snow, let it snow, let it snow. Did I get it? There you are at the Snow Queen's Ice Castle. Oh, did I find you? I betcha I did. Well, I hope you've had fun so far. If you'd like, we can do our picture up next. I'd be so happy to.
Alrighty, and as the Snow Queen is getting ready for her picture, as a quick reminder, everybody, if you post these pictures to Instagram and you tag us here at Varsity Tutors, as well as the Omaha Children's Museum, you'll be entered to win that 1-month membership to the after-school club of your choice. So whether you want to learn a little more about science or maybe branch out into chess or math or history, there is an after-school camp for you. Now, I'm going to go ahead and pass things back along to the Snow Queen for that selfie, and then we've got some really wonderful questions.
Cheese. Oh wait, freeze.
All right, thank you so much. And if you haven't gotten that selfie just yet, the Snow Queen will be here for the next couple of minutes answering some of these wonderful questions. And we have some really wonderful questions. So first off, we had some students who were wondering, the material that you used at the very beginning that looked a lot like snow, do we use that in any sorts of things that students might be familiar with, maybe like artificial snow machines, or we had some questions around ore beads? Do we know where we use that stuff?
So from what I know, it's not super common, but they've used it in movies before. So maybe not as accessible. It's not like the dry ice where you could probably go to your local grocery store and pick some up. But, oh, actually, we have them, so they use them in diapers, which sounds silly, but not for snow effects. So the point of it is that it absorbs water really, really well. And so they're little like water beads. Similar things have also been used in air fresheners. So have you ever seen the ones with beads in them? They just soak them in the perfume, and then as they shrink, they're letting that material, they're letting that scent into the air. So movies, diapers, and air freshener.
Wow, those are some pretty unexpected uses. Now, speaking of that dry ice you mentioned, we had some students who were wondering how safe dry ice is to work with. And so could you give us a quick reminder, how can we make sure that we're working with it safely? And is it safe to work with on their own, or do they maybe need an adult nearby?
Gotcha. That is an excellent question. So dry ice, so it's 110 degrees below zero, as we discussed, but we do have, I would highly recommend, first of all, adult supervision, and then a pair of thermal gloves, ones that are meant to handle things that are very cold. So if, for example, you graze some by accident, your hand won't fall off. But it is very cold. So the problem is that it's so much colder that it can give you frostbite. It can really damage your skin if you're exposed to it for too long. So it is way better to err on that side of safety and keep your safety gloves on the whole time with some adult supervision, even though, yes, you can pick it up at most grocery stores.
Very cool, and literally very cool. Now, we had lots of students who were wondering if you happen to know a certain Princess Elsa and if you have any of her powers.
So, I know her. I am not her. So no, I don't have many of her powers that I can show you here and now. I do have magical powers though, more related to snow than ice though, if that's all right. I suppose fashionably we are a bit similar, not on purpose though. But yes, my hair is light, but I didn't choose it. And I choose to wear my favorite white gown just to match my lovely palace. Great question though.
That is wonderful. And we also had some students who were wondering if there were any other friends at the museum who know a little something about science that maybe they should learn from at some other time.
Oh my goodness, yes. So we have science shows that go on throughout the museum. We've done freezing cold science shows. We have a color and light where you get to learn about the science of light. Coming up next, we have shows about bubbles, shows about forces. It is fantastic. So yes, if you ever stop by the museum, if you're ever near Omaha, we have science going on all the time. So make sure to stop in for a science show in our science show place.
Awesome, very cool. And I know that with Varsity Tutors, we have a couple of other scientists and friends of yours that you could check out some recordings for as well. Now, we were also wondering, or much of the class was, were there any other favorite experiments that you didn't get to today, but that you think students might want to try on their own?
Thinking about that one. It's tricky with cold things. So for example, liquid nitrogen, absolutely not. That one is very, very, very cold. But other cold experiments, I'm sure there are ones with ice. So crystallizing, if you are interested in like water crystals and snowflakes and how those work. If you've ever seen crystal, like sugar candy. So if you have water, and you can look this up, I recommend it. If you have water and you boil it, you can use either sugar or borax works too. And then if you have pipe cleaners and you leave it in the boiling water and you leave it to get cool, what happens is those tiny little bits, the borax or the sugar, whatever you use, are going to cling to your pipe cleaner or stick, whatever you put in, and start to form crystals. So it's not necessarily cold, but it does help you understand how ice crystals function. I'm sure that there are a few more. I have plenty of fun facts, but that's the first one that comes to mind. So sugar crystals or borax, both work, but a super saturated solution is what you need.
Wow. Now, on a similar note, we had some students who were asking about potential substitute ingredients for their at-home experiment today. So we had students who were asking whether they could use things like denture tablets or other things that fizz when you put them in water. So could you talk to us a little bit? Are there some creative ways that we can use alternate ingredients to create our blizzard in a jar?
I'm sure that there are workarounds. Truly, I have not used denture tablets, but I'm quite sure that they work the same way. So actually, if you could just be real scientists and figure that out, test it out. That's what scientists do. So if you're not sure, give it a shot. I haven't tried everything, but those tablets and other fizzy tablets theoretically should work. If you have something that's lighter than water, you could probably use that instead of the baby oil as well. Yeah, you can go ahead and give it a whirl. But yeah, it really should work. I can't see why it wouldn't.
Awesome. And for those of you who did try out that experiment or maybe tested the scientific method and tried out a slightly different version on your own, definitely feel free to include those results in those selfie posts. We would love to see those of you who joined in on that experiment. Now, as one final question to end off today, as the ultimate expert on all things cold, students are just waiting in the wings to know, do you prefer ice cream or popsicles?
Oh my goodness. Oh, wow. Oh, that's so difficult. You know, I'm going to say probably ice cream. I do love popsicles, but full disclosure, I like my ice cream a little bit melty. I know, you wouldn't think so. I love ice castles, but I have a weak point for chocolate ice cream that's just a little bit melty. If you throw in a brownie, it's a done deal.
That is awesome. Well, you heard it here first. Expert opinion on all things cold. That's the best way to ice cream. So is there anything else that you would like to leave the class with? Any of our future scientists and adventurers who have tuned in, participated in today's experiments and want to learn more?
I would say if you want to learn more, keep learning more. Ask those questions. Go above and beyond. If you can't ask your question, write it down or tell someone else and ask it later. Whatever you can do, just jump down that rabbit hole. If you want to find something out, look it up. The internet's a great resource. Your friends, teachers, grown-ups, all great resources. So I think the bottom line is stay curious and keep looking for answers.
Wonderful. Well, thank you so much once again to the Snow Queen and to the entire team at the Omaha Children's Museum. We can't wait to see all of those selfies, so don't forget to post the selfies and tag both Varsity Tutors and the Omaha Children's Museum. And we hope to see you all back in another Varsity Tutors class very soon. Thanks, everybody.